1.4, here we go. We are talking about inequalities. Let's do it. Okay, so we're talking about inequalities. So it's this similar type of a thing as an equation, except it's greater than or equal to. So I'm actually just going to start down here because I like graphing things, and we'll come back. So hopefully you're familiar with like the greater than or the less than symbol. Again, it just means like this value and bigger than, or this value and lower than. But you should hopefully remember that this symbol stands for greater than or equal to, and in which case you will use, let's see here, so that's 8. So if we were just to label this 6, 7, 8, 9, 10. So if you were to graph it, it would look like this. It's a solid dot, and an arrow goes for that. So that represents all of these values. That includes 8. So we represent that with a solid dot. And then we'll come back to that. So without that equals, that means that we don't include that value. So if we come over here to number 2, again, so let's just label our -3, -2, -1, 0, 1, so on and so forth. So that A is less than -1. That means that it does not include -1. So whatever this expression is talking about, it's about all the values that are less than -1. So we would do an open circle and an arrow. You can also do it like above the number line if that makes you happier. If you can see it better, that also works. But the important part is that this open circle right there means that it is every value that is less than -1, and it does not include -1. So if we go back up here, we can finish some of this stuff off. Graphing inequalities, use a closed dot for less than or equal to, greater than or equal to symbols, emphasis on the equal to part, and use an open dot for less than or greater than. So again, remember, like, the little chomping mouth always faces the bigger number, right? So the next part we're going to talk about is this thing called interval notation. So this is just a way to write, another way to write if we didn't want to draw a whole picture or write an equation. So if we are referring to this interval, we're back at number 1, it is all values including 8. So we have parentheses that we can use that does not include or open, and then brackets that we can use that indicate included or closed. So what that looks like is, since that 8 is included, and it's going 8 is the lowest number, and then we're going up, we're going to do a square bracket, 8, comma, and then since it goes on for forever, we kind of have a symbol for forever. It's infinity, right? So we do a little infinity. And note that we always use a curved or a parenthesis for infinity, because you can't ever include infinity, because it's a concept, it's not a number. Like, how do you have an infinite number of something? It's not a thing. It just goes on forever. So up here we could say where the parentheses we're talking about, that's these things, and then the brackets are those things. So then if we move over to number 2, one of the ones we've already talked about. So we're talking about -1 and everything lower, but we don't include -1. So the interval notation always goes from left to right, lowest to biggest. So it's going to go from -infinity up to -1, but we're going to use a parenthesis because we're not including this number. So parentheses you don't include, square brackets you do include. So the hope here, that's kind of the concept of how inequalities work or what they mean, but we also want to solve inequalities similar to how we solve equations, right? It all works almost the exact same way except for a few minor differences. And those minor differences are right here. So it says, follow the same rules to solve an inequality as you would an equation, except you will switch the inequality symbol if you multiply or divide by a negative number. So it's really important that you keep track of your negative signs because they can make your inequalities switch back and forth. So what does that look like? We're here on number 3, and we are trying to solve, graph, and then write the solution of each inequality. So we're going to first solve it just like an equation, except we're going to keep track of any time we divide or multiply by a negative. So just like we would normally do, we're going to get all of the V's on one side and all the numbers on the other side. I'm going to do the V's on the right just because it's bigger. The 7 is bigger. So we're going to subtract 5V from both sides. And hopefully by now you're a little bit more comfortable with this algebra. So I'm going to do 2 steps and 1. We're going to move this guy over to the other side as well. So we're going to add 17 to both sides. So what we got afterwards, we have 17 plus 1 is 18 is greater than 2V. Okay, so we haven't changed our sign. We just brought it down so far, or your inequality sign. Gotta get the V by itself, so we're dividing by 2. Divide by 2. 2 is not negative, so nothing weird happens. So we've got 18 divided by 2 is 9 is greater than V. So that means that our solution is all numbers that are greater than 9, not included 9. So then what that looks like, let's see here, we can just do 9, 10, 11, 8, 7. So we're going to put an open circle on 9 because it doesn't include 9. And 9 is greater than V. Oh, I told you wrong. So all of our solutions are numbers that are less than 9. So that means that it's going to go this way. So make sure that you understand the different symbols. So V, this is all of our numbers, all of our solutions are all less than 9. So you can rewrite that V less than 9. That might be a good idea, just to make sure you get it right. So then if you wanted to do interval notation, again, interval notation is just another way of describing our solution. So we're going to go from negative infinity to 9. We use a parenthesis for negative infinity, parenthesis for 9 because we're not including. It is not equal to 9. It is less than 9. Okay, we're warmed up, so let's try a good one. So here we've got a couple of things going on. So can't forget your properties. So the first thing I'm going to do is I'm going to simplify it, which means that we're going to distribute the 3 out, deal with that. So we've got 21x minus 15x minus 27. So all I did was distribute that 3 out, greater than or equal to 7. Okay, so we're simplifying. We have some like terms here. Let's just go ahead and combine those, which is 6. So 21 minus 15. So we've got 6x minus 27 is greater than or equal to 7. So then we can add 27 to both sides. We've got 6x greater than or equal to 34. And we got x greater than or equal to 34 divided by 6. 34 divided by 6. We're just going to try to simplify that as much as possible. So let's see, I can pull a 2 out. So 2 divided by 34, 17, right? Yeah, 17. And then 6 divided by 2 is 3. That's about as low as we go. So our solution is x is greater than or equal to 17 over 3. So that's a weirdo number. It's in between 5 and 6. So, if we were to label our number line, I guess we can do like 17 over 3, 16 over 3, and just call it 5, 6, and then blah, 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 blah. Whatever, I don't care. So 17 over 3, it is a greater than or equal to, so we are going to use a filled in dot, and x is bigger than that number. So all of our solutions are up here on the number line. So then if we were to write that in interval notation, so our lowest number is 17 over 3, and that number is included, so we're going to use a square bracket, comma, and it goes up to infinity. So at some point later on, we will have a closed interval, and that's where we're going to see less infinities, and you'll just have from one number to one number. I skipped over to number 6 so you can see some inequality switching action, and just because it's fun, why not? So number 6, again, we got some parentheses, we got some other stuff, so let's just simplify it, see where we get. So we're going to distribute that negative sign to all of these numbers. So that means that we're going to have 3 minus 4m minus 1 is greater than or equal to 5m minus 25. Again, you don't mess with the inequalities unless you multiply or divide by a negative number. Okay, so we've got that number. Let's go ahead and combine like terms. So we've got 2 minus 4m is greater than or equal to 5m minus 25. See, I'm already thinking in my head how can I just keep this number positive? But just for funsies, we'll move all of my m's over to that side, and then all my other numbers to the other side. So we're going to have minus 2 on both sides, minus 5m on both sides. Got negative 9m. And negative 27. Makes me feel bad. I thought it was 26 for a second. So here we're going to divide both sides by a negative 9, which means we have to flip our sign. So what that ends up happening, we're going to have m is less than or equal to whatever 27 divided by 9 is, which is 3. You'll notice that when I was talking, I just dropped the negative signs because I knew that a negative divided by a negative is a positive. So in my head, I just dropped that negative sign. I do that from time to time. Sometimes it works, sometimes it doesn't. Just be careful with your negative signs. Anyway, here's our answer. So if we're going to graph that answer out, m is less than or equal to 3. Oh, geez. I hate making these number lines. 3, 4, 5, 2, 1. Sure, why not? Less than or equal to means we're using a solid dot. And M is less than or equal to. So it's going to be looking something like that. So then interval notation is kind of more of a formal way of doing it. Or use like it would be the equivalent of like using words as opposed to drawing a picture. And here we're using math language. So our lowest number is that negative infinity over here. And it goes up to 3. Can never include negative infinity, but we do include 3. So it looks like that. There you go. So one other thing that you should kind of know, another way to write all of these interval type things is something called set notation. So this stuff right here. So set notation is just another way of expressing a solution to an inequality. You will see set notation a lot in like more math classes and stuff like that, especially if you go into get a degree in math. They love set notation. But not super important for this class, but it's just kind of good to know because you might see it on like the ACT or something obnoxious like that. So if we have our example, x greater than 5, in set notation, it would look like x such that x is greater than 5, and that is a set value. So then it is read as kind of how I said it, the set of x values where x is greater than 5. So the set of x values where x is greater than 5. So again, either the set of x values where x is greater than 5, or you heard me say it as like, the set of x such that x is greater than 5. So it's up to you. Not a huge deal in this class. Other than maybe this chapter, I'm not going to test you on set notation over and over again, but it is definitely good to know, and it is good to be able to recognize that when you're reading some of these problems. So with inequalities, you can actually have a couple inequalities combined. So we were talking about those intervals a little bit earlier, and this is just another branch of that interval type stuff. So a compound inequality is two or more inequalities graphed together on the same number line. So we can write that. Two or more inequalities graphed together on the same line. So, and there's two types of inequalities that we're going to talk about, the or inequalities and the and inequalities. And that'll make more sense a little bit later. So we're going to start with the or. So our first type is the or inequalities. Their graph is going to look something like that. But it's written like after you do all the work and whatever, your solution will look something like, x is less than or equal to -4, or x is greater than 1. So that's what we're looking at right here. So notice that that x is less than or equal to -4, that's this part right here, or x is greater than 1. So that means that the solution can be anywhere in this interval or anywhere in this interval. So then if we wanted to do like the interval notation, so we would just do this guy, and then I'll show you a cute little or symbol in between. So we've got negative infinity to negative 4. It does include 4, does not include negative, does not include negative infinity. And our or symbol is just kind of like a U. There's no tail there, don't put the tail on. So that stands for or. And then we do this top part. Make sense? Let's try it out. So let's solve or inequalities. All you have to do is solve each individual part, just like we've been doing, and then put them together. Throw an or in between them. Sounds easy, but we'll see. We can always get lost in the weeds. So if we start with this number 1 here, we've got 3x. Oh, no, I'm sorry. We've got this guy, and we've got this guy. So let's just solve them individually, and then we'll put them back together. So we want x greater than or equal to blah, 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 blah. Then we want x greater than or equal to blah, 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 blah. So long story short, x is on the left side. So we're going to put all of our numbers on the right. -4, -4. We've got 3x less than or equal to 6. X less than or equal to 2. I divided both sides by 3. Okay, so over here, we'll just divide both sides by 5. We get x is greater than 9. 45 divided by 5 is 9. So then you put your little or. There's your answer. Okay, not quite. We're not quite done yet. So if we wanted to graph that, what does it look like, visually down here? So x is less than or equal to 2, so we find 2, and it's going to be a solid dot. And then x is less than, lower than 2, so we're going to draw a line over here. And where we draw the line, our solution can be anywhere in somewhere on this line. Oh my gosh, it's a lot of dashes I just made. Okay, so that's that part. So now we got to deal with this part. X is greater than 9. So we're going to find 9. We're doing an open circle because there's no equal then there. And we're going that way. So that is our graphing, if you will. So our interval notation, so this part right here would be negative infinity to 2, parenthesis around infinity, 2 is included, so it gets a square bracket. Or, that's our mathy symbol for or, 9 up to infinity. And again, can't include infinity because it's just a concept, not a number. So there you go. Let's keep going. So for number 2, we're going to do the same thing. We're going to solve this guy, and then cram them together with an or. So we're going to -6 from both sides. So that means we got n is less than or equal to -1. And then on the other side, we'll -7 from both sides. Then we got 9n less than 36. And then divide both sides by 9. 9 is greater than 4. So then we'll move this guy down just so that it looks pretty. Or, and there's your answer. Still not done yet. We got to graph it, but that's our start. So if we graph that first part, n less than or equal to -1, find -1. It's a solid dot because it's an equal. Whee! So n is less than or lower than -1, or n is greater than 4. Doesn't include 4. Whee! And then interval notation, negative infinity to -1. We include -1. We do not include infinity. Or, fancy symbol for or, 4 to infinity and beyond. The second type of inequality is going to be an and inequality. So prior we had, either this could be the case or this could be the case. In this case, with the second type of an and, it's this is the case and this is the case. So it creates an interval. So we can see that right there. So they graphed one out. So that would be written, that type of interval would be written like x is greater than or equal to -2 and x is less than 5. So the x is greater than -2 is this part right here, and then the x is less than 5 is this part right there. And the interval is those little guys in between. So that's kind of the difference between an or an and. So if we were to write that in interval notation, it's even easier. I love that part because it's just one single interval. It starts at -2 right there. It includes that, so it's a square bracket, and it goes until 5. But it does not include 5, so we use the parenthesis right there. So that's all. So because it's a interval, we can also shorten the written part of it. So instead of going x is greater than -2 and x is less than 5, what you will see instead is -2 is less than or equal to x, which is less than 5. So this is commonly how it's going to be written. So again, when you're doing this part, or when you see that, or if you ever start writing that, note that these two signs are going the same direction. You don't want to be in a situation where they're like going in the two different directions. So just be aware of that. So solving the and inequalities is actually the same process as solving the or inequalities. You just get a slightly different answer. You're going to you're going to solve both sides, and then you'll essentially and them together or connect them together. So here we go. We'll start with this guy right there. We're going to get everything over to the left side. I'm sorry, all the x's over to the left side already is. We're going to -3 from both sides. So we got 2x greater than -12. 9, 10, 11, 12. Yeah. So then x is greater than -6. We divided both sides by 2. So then this side, we're going to have 8x is less than 30 plus 2, 32. X is less than 32 divided by 8 is 4. And then we got to bring our and down so we can write and. Okay, so that is one answer, but I'm going to have you guys put them in some kind of an interval. So then that would look like -6 is less than x, which is less than 4. So we just kind of connect the two x's. And again, theoretically, our intervals should be going the same direction. So to finish that problem, hopefully without pushing the back button, to graph this, you're just going to start at -6. It's an open circle because there's no equal to sign, and up to 4, and it's going to be everything in between those two numbers. So that is actually your solution. The solution lies somewhere in that interval. Interval notation, -6, parenthesis, because it's not included, -6 to 4. Done. So you can try those other problems yourself. I went straight to number 12 because it's kind of gross looking, and I wanted to do number 12 anyway. So here they've already put it into that kind of notation, so we already know that it's an and statement. And so we can just split them up. We can separate them out. But before we do that, we can kind of clean it up a little bit. So remember, we've got two equations here. So anything that we want to do to this middle, we have to do to the outside ones. Same thing's true with the outside. If we do something to the outside, we got to do something to each one. So fractions are gross. Nobody likes fractions. So we're going to multiply this by -2, multiply this by -2, multiply this by -2. So then what we're going to have is we have 10 negative plus negative, or times a negative, less than or equal to 12 minus x less than a positive 4. Okay, so again, same thing. We want to get this 12 out of here. So we're going to minus the 12. Got to do it to this side. Got to do it to this side. So then we're going to have a -2 less than or equal to -x less than, oh, what is that? Negative a thing, 8. Yeah. So now we've got all these nasty negative signs. So we're going to divide everything by -1 or multiply by -1, whatever you want. But we're going to switch signs, right? So if we multiply by a -1, that means that we have to switch our signs or switch our inequalities. So then what we've got left over is 2 greater than or equal to x greater than 8. I almost wrote -8. So then to graph it out, find the 2, find the 8. 2 is a solid dot because it's a greater than or equal to. 8 is an open dot. And then we connect the 2 in between. Interval notation is 2 to 8. Done. How exciting.